A thermostat, a Roomba, and an AI that writes code all get called agents. They're not even close to the same species of intelligence. There's a hidden ladder connecting them, and today we're climbing every single rung of it. Let's start at the bottom. The dumbest possible agent, and I mean that with love, is a simple reflex agent. Its entire brain is 3 boxes: sensor input, a fixed if-then rule table, and an actuator that acts. That's it. No memory, no planning, just knee-jerk reaction. Think about a drone that swerves the instant it detects a branch. It's not thinking, there's a tree, I should reroute around the forest. It just sees obstacle, dodges, moves on. Traffic lights on fixed timers. Thermostats that heat when it's under 70 degrees. Factory shutoffs triggered by vibration. The doors that slide open at the grocery store. All level 1. Fast, cheap, dirt simple. And the second the environment gets unpredictable, they break. So we give it memory. That one addition, an internal state buffer, changes everything. Now the agent can track things it can't currently see. Picture that same drone flying past a wall. A flock of birds just went behind it. The drone can't see them anymore, but its internal model keeps tracking their hidden trajectory anyway. That's the leap. Memory plus reflexes. It's why your robot vacuum knows which rooms it already cleaned. Why a self-driving car keeps tracking a car that's briefly hidden behind a truck. And why an elevator remembers every floor call, even while it's busy somewhere else. More capable, but also more compute hungry. Memory is nice, but it still doesn't tell you where to go. That's level 3, goal-based agents. Now the system is simulating the future, running out entire branches of possible action sequences and asking, will this specific path actually reach the objective? This is your GPS calculating a route around a closed road. It's a chess engine calculating 5 moves ahead to checkmate. It's a Mars rover plotting a path around boulders to reach a sample site. The agent isn't just reacting anymore, it's planning. But here's the problem with pure goal seeking. It only asks, does this reach the goal? Yes or no. It doesn't ask, is this a good way to get there? Enter utility-based agents, the ones that weigh trade-offs. Picture a delivery drone choosing between a fast route through high wind or a slower route that saves battery and stays safe. It's scoring speed against cost, against safety, and picking the best overall outcome, not just a working outcome. This is your rideshare app pricing a trip in real time, a financial agent balancing risk against return, a recommendation algorithm ranking what to show you next. Multi-criteria decisions, made under uncertainty, which means they live and die by how carefully their scoring is designed. Every level so far has one flaw. The rules are fixed by the humans who built them. Level 5 breaks that. Learning agents improve themselves, a loop of a performance element acting, a critic judging the result, and a learning element rewriting the rules based on what worked. This is how AlphaZero went from knowing nothing about Go to superhuman in days, playing itself over and over. It's a customer service bot getting better every time it resolves a ticket. It's ad tech reallocating budget in real time based on what's converting right now. The catch? The more it learns from its own experience, the more it becomes a black box, even to the people who built it. So far, we've talked about one brain. What happens when you have hundreds? Multi-agent systems are independent agents that communicate, negotiate, and split up the work. Sometimes cooperating, sometimes competing, sometimes both at once. A warehouse full of robots silently dividing up which shelf to restock next. Self-driving cars negotiating who goes first at a 4-way intersection. Trading bots competing against each other in the market, millisecond by millisecond. Highly scalable, resilient if one agent drops out, but coordinating all of them is its own massive headache. And when a task is too big for any flat network of agents to sort out on the fly, you add a chain of command. Hierarchical agents split intelligence into layers. Strategic thinking at the top, tactical breakdown in the middle, operational execution at the bottom. One manager drone assigning zones to captain drones, which then direct individual delivery drones on exact routes. It's how a national delivery network routes a package, hands it to a hub, then executes the final flight. It's how a factory schedules an entire plant, then a line, then a single machine. Built-in redundancy, real scalability, at the cost of some lag between the top of the chain and the bottom. Okay, here's the moment that actually matters. Take goal-based thinking. Add utility scoring. Add learning. Add hierarchy. Multiply all of it by a large language model acting as the reasoning engine. That equation is modern agentic AI. And here's the part almost nobody tells you. The agentic AI wave that's blown up over the last 2 years is not a brand new category of computer science. It's the realization of AI architecture that's been theorized for decades. Except now, instead of brittle, hand-coded logic gates, you've got a large language model doing the reasoning, the planning, and deciding which tools to use. Same skeleton, new brain. So what does that new brain actually look like in motion? It runs on a loop. Observe, think, act, over and over, autonomously. A planning module breaks your one-line request into steps and actually reflects on whether those steps are working. A tooling layer lets it reach out into the real world, browsing the web, executing code, querying a database. And a memory module holds both short-term context for right now and a long-term vector database for everything it's learned before. Here's what that looks like end-to-end. You type one sentence. The agent reads your request, checks a live weather API, writes a quick script to unlock a smart door, and leaves you a personalized note, all on its own. It's using language itself as the operating system. This isn't theoretical. It's already running inside real companies. In 2026, the standard setup is an orchestrator agent sitting on top, delegating out to specialists. A retrieval agent, a code execution agent, a data analysis agent. Insurance companies are using it to read messy claims and route tickets adaptively, instead of relying on brittle, rule-based RPA. Retailers are running orchestrated agents across voice support, inventory, and staff training in every store, worldwide. Banks are coordinating agent teams that handle intake, summarization, next best action, and audit, all on a single customer case. And in engineering, coding agents are planning, writing, running, and debugging code across entire repositories, mostly unsupervised. So let's zoom back out. Here's the entire ladder as a cheat sheet. Memory, an explicit goal, the ability to weigh trade-offs, the ability to learn, the ability to work as multiple agents, and complexity climbing every step of the way. Simple Reflex agents check almost none of those boxes. Modern LLM-based agentic AI checks every single one. Everything in between is just a matter of how many of those capabilities got layered on. And that's really the whole point. Intelligence isn't a monolith, it's an architecture. Reactivity, state tracking, foresight, adaptation, scale, and finally autonomous reasoning, stacked one on top of the next. The autonomous enterprise swarms everyone's racing to build tomorrow. They're not replacing the logic gates of yesterday. They're built entirely on top of them. If this gave you a clearer map of where AI agents actually stand right now, hit subscribe, because we're going to be climbing a lot higher on this ladder in videos to come.